Hello class, welcome back. Today is lecture 13. Today we're talking about solving quadratic equations. So we've already sort of done this a little bit. So like before we learned how to solve things like this. We can solve equations, like this, but we can't do it all the time. The only time we could do it is if we can factor the left side with our little box method here. But our box method won't always work. We only worked on problems where it did work, but it doesn't always work. So this one is it won't really work the same. So what do we do in this situation? And that's the idea. So what about when we cannot factor? What are we supposed to do? How do we solve things like this? These are called quadratic equations. And we solved some quadratic equations already by factoring, but now we want to be able to solve all quadratic equations, ones where we can't just factor. Okay, so we're going to sort of build up to the technique, the big technique, through some smaller examples. So in the following example, we can use the square root function or idea to solve. So something like this. Now it's not as easy to factor because it is a difference of squares, but you have to think about really hard why it's a difference of squares, but it's not an easy square like 9 or 25 or something where you could use that formula very easily. So instead, what we can do is we can add 10 to both sides and get something like this. And then we actually get two answers, which comes from square rooting. And they are the square root of 10 and negative square root of 10. So why are these the two answers? Well, the quick thing people do is they'll do something like this. They will say we have this, and then we're going to square root both sides, but you introduce a plus or minus when you square root. So you get x equals plus or minus square root of 10. And that plus or minus represents the fact that there's two answers. So this is the plus one, and then this is the minus one. So that's the sort of quick method, but it's really because the square root of 10 squared is 10. And so is if I put a negative on it and I square that. When you square a square root, you get back to the number on the inside. So you still get 10 again, but now negative 1 squared is positive 1. So that's why you still get positive 10. So that's the idea. And so this counts as a quadratic equation, even though it doesn't have an x term. It only has an x squared and a number term. Still counts as a quadratic equation. And so we can solve ones that look like that pretty much always the same way. So x squared minus 3 equals 0. You just add 3 to both sides, and then you square root both sides. And you get two answers, the positive one and the negative one. Of course, if it happens to be a nice number that has a good square root, this is equivalent to what we did before. So here you get positive 3 and you also get negative 3. But this is the same as if I just factored because it's a difference of squares. And then I set each one equal to 0. Then I'll get my 3 and my negative 3 still. So it's the same as factoring. So that's good. Square rooting is going to come in handy. And it's going to come in handy for slightly even more complicated things. Something like this. So this is going to be a bit different than anything we've seen before, but instead of just having x squared, what if we have like a whole bunch of stuff squared? And then we have some other junk going on here, something like this. Well, we can actually solve this the same way. The idea is that instead of getting x squared alone, you want to get this thing alone because it's squared. And so I can undo the square by square rooting. So we can square root to solve. Not for x, but for 2x plus 1. So instead of getting x squared alone, which is what we're doing here, we're getting whatever is squared alone, which is 2x plus 1. So how can I get that alone? Well, all I have to do is subtract 4 to both sides. And then I'll end up with 2x plus 1 squared equals 16. So that's all we're doing there, subtracting 4 to both sides. And now, like I said, because this is alone, I can square root both sides just like before. And I get 2 answers again. So then I get 2x plus 1 because square rooting a square takes it away. And then the square root of 16 is 4, but it's also could be -4. So I once again get 2 equations, which is basically what happened up here, except the equations were already solved for x. So it's the same as before, it's just a little bit more complicated. So these equations are not yet solved for x, and now we solve them both for x. So subtract 1, and we got to divide by 2. And then that'll do it. 3 over 2 and -5/2. So this is how we solve for x. Same idea, just a little bit more complicated. And this is what's going to motivate our technique, actually doing something like this. Noticing that it doesn't just have to be x squared, but it could be some bigger expression squared like this. And as long as I have that, I can square root, and that'll help me solve. So this helps us solve things like this. So let's see, x squared plus 4x minus 6. Can I just factor this one? I don't know, I just made it up. But let's just pretend we can't factor it, even if we can. So this helps us solve things like the following, not exactly the same way, but by some technique called completing the square. The quote's over here, actually. Completing the square. So the idea is I want to turn the left side into something squared, aka like this, 2x plus 1 squared, something squared. I want that to be something squared. That way I can square root both sides. And what we're going to do is we're going to use these little shortcuts that we saw a while ago, which is if I square something like this, x plus a squared, and I multiply it out, I get x squared plus 2ax plus a squared, or you can also do it with a minus a. Make it minus 2ax instead. So we're going to use this fact, except we're going to sort of go backwards. The idea being, if I have something that looks like this or like this, I can factor it into something times itself, something squared. So that's what we're going to try to do. Okay. So that's what motivates the idea. So now we take our thing on the left, x squared plus 4x minus 6, and we really wish that it would look like either this one or this one, so that I could then factor it into something times itself. So how can I do that? Well, all we're going to do is we're going to consider the middle term 4, and the idea is that this guy is double this thing squared. So I'm going to take that thing and I'm going to cut it in half. So I'm going to always divide by 2. and then I'm going to square it. And if that's a squared, if I stick that there, then it'll be factorable. So that's what we're going to do. So 4 over 2 is 2, squared is 4. So now, if I just sort of squeeze this 4 in here, I just add it in there, then this looks like this, where a equals 2, right? Because 2a is 4 and 2 squared is 4, so it's all matching up, and then this will factor. Of course, you can't just forget about the 6. It was there, it's still there. You can't change an equation, or else it's a different equation. And right now I have changed this equation, so it's not the same as what I started with. But I want it to be exactly the same. I want it to be exactly equal to what I started with. Well, what I need to do now is I need to subtract a 4 because we added a 4. And so we need to not change the equation, to not change the expression. So I need my 4 and my minus 4 to cancel to be 0, so that together, by adding this 4 and subtracting this 4, I secretly haven't added anything at all. I've added 0. And so this is not changing the expression at all. Okay, so this is how the trick works. So we'll get lots of practice with it, but this is the trick. So how do I use this trick now? So then the idea is I'm trying to solve this guy. And what am I doing to it? Well, I'm adding a 4 here. You don't need these parentheses, but it's nice to keep things together. And then I'm going to subtract 4 as well, so that it doesn't change. And now the idea is that this thing will factor. It'll always factor into x plus, or if it's a minus, it'll be minus whatever number it was before you squared it, so 2. And then that is squared. And then I'll just combine these together. And now I have something sort of like the earlier problem. So let me scroll back up. So now I have something that sort of looks like this guy, where now I can solve for x by getting the thing that's squared alone. So that's what we're going to do. So all I have to do now is add 10 to both sides to do that. And then I can solve for x by square rooting both sides, just like I did up there. And I get 2 answers because this becomes a plus or minus. And now I have my 2 answers by just subtracting 2. So x equals -2. We typically like to put the number without the square root first. It just looks nicer. And you don't combine them really, anything like that. You just leave it like this. Okay, so here we also subtract 2. And so these are my 2 answers. Okay, so we'll run through this technique a few times in some other examples, but the idea will always be the same, which is we have to figure this thing out, and then we have to add it and subtract it. And then when we do that, we create something that factors into x plus something squared. Okay, so let's do another example. Just to see. So it can vary a little bit. Some things will make it a little bit harder sometimes. And let's see that now. So here I'll break it down into steps. So step 1 is this technique is only going to work if x squared is sort of alone. So what you need to do is you need to factor out the number in front of x squared from the x squared and the x term. So what that means is this 2's got to go. So I'm going to take out this 2 from x squared. It'll just leave me with x squared. But I also got to take it out from the 8x, and that'll leave me with 4x. And then what you want to do is leave a little bit of space. And you're not going to take it out of the number. The number is just going to chill there. You're just taking it out of the x terms. It's a bit weird to do, but it'll pay off in a second. And the idea is that I really want this to look like x squared plus 2ax plus a squared. So I don't really want a number attached to my x squared in order for this to work. And that's why I do that. So step 2 is calculate whatever this number is over 2. Always divide by 2. And then square it. So this is just going to be the same as last time, but that's okay. We'll do other ones as well. And then you end up with 4. So that is what we're going to add and subtract, but it's going to be a little bit different this time. So now add 4 inside this extra space that you have. I'll rewrite it, but this is why there's that extra space there. So I want to add that there. Now, what number was that? Sorry, 5 now. Now I do not want to just subtract 4 like I did last time. So that's not right this time. So why not? Well, because secretly, I didn't add 4. I actually added 2 times 4. So now I need to subtract 8 to make it not change. So I have to subtract 8 to keep the equation the same because of this 2. So that was not right. So instead I have to subtract 8. And that ensures that I added and subtracted the same amount, which is 8 on the left side of the equation, so that it doesn't change the equation. Okay, so now I can factor and simplify. So the whole point of this technique is that it allows you to factor this thing as a square. So it becomes x plus 2 squared, because it's always going to be whatever this number was before you squared it. And it was 4 over 2. It was 2 squared. And then the rest of it, you just simplify by sticking those numbers together. And now I can solve for x by adding the 13 and getting this squared piece by itself. So now I just have to divide by 2 on both sides. And so they'll often be annoying fractions, but that's okay. 13 over 2, we're just going to leave it like that. Now to get rid of the square. So the whole point was I can now square root both sides, and it introduces a plus or minus when I do that. So I end up with x plus 2 equals positive square root of 13 over 2. And then my other solution will come from x plus 2 equaling negative square root of 13 over 2. And the last step is just to subtract 2 on both sides, on both equations. And we typically like to stick the number without the square root on the front. So we'll do that. And those are our 2 answers. Okay, so let's just keep going. I might keep numbering the steps, or I might not. It's hard to remember the numbering system, but I feel like to speed it up as we go. So maybe I'll just do that. Okay, so let's do another one with a slightly different twist. Okay, so I'm not going to write down the steps, but I'm going to do them. So first thing is I need to now realize there's a -3 here. So I got to take out a -3 from my x squared. So it'll be nice and alone, just x squared with a 1 on it, secret 1. But I got to take it out of that 18, and that'll give me a -6. Then I got to leave some space. And now I got to figure out what goes in that space. So I have to think about this number here. I have to divide it in half, and then I have to square it. And it is going to matter that it's a -3 instead of just a 3, although when I square it, it becomes +9. But when I factor, the fact that it was negative will come back into play. Okay, so I added a 9 there. So that means I need to subtract something as well. What do I need to subtract? Well, this is another tricky one. So I really didn't add a 9 to the left side. I really added a -3 times 9, a -27, because when I stick that 9 there, it's actually getting multiplied by that -3. So I'm really adding a -27. So now I need to add a +27 to cancel. So my equation really becomes -3x², what was it, -6x plus 9 minus, plus 5, and now plus 27. So this time I have to add 27 to cancel the -27 that I've secretly added. Okay, and now I just simplify. So in factor, so this guy is now going to factor into x -3² instead of x plus 3². Again, that -3 is coming from here, the number we had before we squared it, which was a -3. And then 5 and 27 make 30. What was that, 32? So now I can solve. So I'm going to subtract the 32. And this is now the smooth sailing part. We're just about done. Just divide both sides by -3. So the negatives will cancel, but unfortunately we're stuck with another fraction. And now I can square root both sides, which introduces a plus or minus, and that gives me 2 equations to solve. This one, positive square root, and this other one, negative square root. Okay, so then I just got to add 3 to both sides, and I am done. So again, I'm going to put the number in front of the square rooted number because it just looks nicer in both situations. Okay, so those are my 2 answers. So sometimes you can simplify the square root part, but I'm not going to be overly concerned with that. Let's just keep working on this technique. So I think I want to do one more and then sort of switch it up a bit, just to see, just for practice. So here we have the number on the right side. So you don't have to do this first step, but I can move everything to the left to make it be the same as it was, or I could keep that 10 on the right. So let's keep that 10 on the right, actually, just to see the difference that it makes, which is no difference. Okay, so again, I'm going to start off by taking out this 4 from the x² term, and that leaves me with the 8x there, and then I'm going to leave some space. And now I need to consider my middle term. I need to cut it in half, and I need to square it. So I end up with 16. So I'm going to add, well, I'm not technically adding 16. I'm technically adding 4 times 16 equals 64. And that means I need to subtract 64 as well. So we're going to end up with, oops, it was a minus, sorry, minus 8x. Wrong color. Minus 8x. So I'm, like I said, I'm going to add a 16 here, but secretly that makes me add 64. So now I need to also subtract 64. And then that, what was that on the other side? 10. We can just leave it there. Okay, so now I can simplify, and that means I can factor this guy. So this is going to factor into x minus 4, because that's what it was before I squared it. It was a -4. So again, that's where that's coming from. and that becomes that thing squared. And then I can also add this 64 to the other side if I want. So I get 74. And now I just have to divide both sides by this 4 on the outside, and I get another fraction. You can reduce it if you want. I'll just leave it for now. Whoops, like that. And now I will square root both sides, which introduces the plus or minus. So I get x minus 4 equals the positive square root, or the negative square root. And finally, to finish the problem, I add the 4 over. And so I get the 4 plus the square root of 74 over 4, and 4 minus the square root. So you should notice that we keep getting 2 answers. We typically get 2 answers. There are cases where you'll just get 1 answer. You may see an example like that, or you may not. All right, so the next thing I want to talk about is that this is the same as using this fancy guy you may have heard about a long time ago, the quadratic formula. So I hope the title, solving quadratic equations, invoked this formula into your brain, because of course quadratic formula better be used to solve quadratic equations. And it is, that's exactly what it does. It basically does what we just did in a one big shortcut. So the idea is that if you have a quadratic equation, that means you can write it as a number times x squared plus a number times x plus a number. So these 3 things are just merely always numbers. It could be 0. So that means that they wouldn't be there. Some of them could be 0. But the point is that they are numbers. And when this happens, then the solution after you do completing the square will always sort of look the same. And so we can just simplify it and write a big formula. So what'll happen if you sort of backtrack this, you'll see that it's actually the same formula. This guy here is always going to be the same as okay, sorry. That number will always be the same as b divided by 2, which you'll notice is what happened here. 8 divided by 2 is 4. And so let me just write it down. Okay, instead of trying to match everything. So the idea is if you write it in that form, then instead of doing completing the square, you can simplify your life by realizing that the 2 answers will always look like this. Negative b plus b squared minus 4 times a times c over 2a. And your other answer will always be negative b minus the square root. So notice we do keep getting that. We always get something plus the square root, something minus the square root. That's always what happens. And the quadratic formula reflects that. Minus 4 times 8 times, everything else is the same. Okay. So these will always give you the same solutions as if you did completing the square. So one last example. Let's just do it like this. So this, I want to show you how you always get the same answer. So in general, before you just run in doing completing the square, you should try to make your life simple. So first you should see like, oh, can I just factor? First try to factor, then give up and use the completing the square or quadratic formula. But always try to factor first, because hopefully it's easy. Always do the easy things in life first. So this one is factorable. So I can factor this into x plus 3, x plus 1 equals 0. So I get my 2 equations. and I subtract 3 on both sides here, and I subtract 1 on both sides here to get my 2 answers. So I don't have to do it the long way, but I am just to show you that they are all the same way. So that's the easiest way. That's factoring. So now let's do completing the square. So for completing the square, I need to consider 4. I need to cut it in half. And I need to square it. So that'll just give me 2 squared, which is 4. So I need to, whoops, x squared. So now I need to add 4. But then I also have to subtract 4 to make it not change. Notice I didn't have to factor everything out of the x squared this time because it was already nice. And now this guy will factor into x plus 2 times x plus 2, aka x plus 2 squared. And these will combine into -1. And then I'll add 1. And then I will square root both sides. So the square root of 1 is 1, or introduces a plus or minus. The square root of 1 can also be -1. So then I just have to subtract 2 to both sides, and voila, I will get the same answer. -1 and -3, which is what I got before. And lastly, the quadratic formula. Here, I just have to identify that A is 1, B is 4, and C is 3. So A is 1 because when you don't write a number in front of the x squared, you're multiplying by 1 technically. And then the quadratic formula says my 2 answers are -b. So people like to write the plus and the minus together. So they usually write plus or minus like that to represent their 2 different answers. Square root of b squared is 4 squared minus 4 times a is 1 times c is 3 for 2 times 1. And we just need to simplify to see that this is the same. So this becomes 16 minus 12 over 2. And then this becomes 4, the square root of 4. So this is why we preemptively introduced the plus or minus in this formula. It's already there. So the square root of 4 is 2 or -2. So you can write one answer with the 2, and then you can write one answer with the -2. And then you get -4 plus 2, that is -2 over 2. And you get -4 minus 2 is -6 over 2. Now, very often you'll just be stuck with fractions that don't simplify, but these two do. So why not simplify? You get -1 there, and you get -3 here. And so that's going to be just about it. One little piece of warning is that when you use the quadratic formula, sometimes this inside might be a negative. And that'll tell you that there's no real solutions because we're not going to deal with taking the square root of negative numbers in this class. So you just say that there's no real solutions. And that can also happen when you do completing the square. So notice that I added 1 on both sides here, but if I ended up with a negative number and I tried to square root both sides, that would have also been bad, and I would have had a square root of a negative there. Okay, so if you see something like that when you do examples, we're just going to say that there's no solution, no real solution. Okay, so that's it for today. See you next time.